With Chapter 7, we're going to look at different types of chemical bonds. And so with this video, we're just going to introduce chemical bonds. So a chemical bond is a force of attraction between either atoms or ions. And this occurs when atoms share or transfer their valence electrons. And so remember from the last couple videos that valence electrons are their outermost electrons. So they're in that outermost energy level. And when we create chemical bonds, we're either going to make molecules, crystals, or other structures. So chemical bonding, we like to diagram it, and we can diagram it with something we call dot diagrams. And so you should become familiar with these because we'll see them quite a bit in these images. So hydrogen has, it's in that alkali metal family, and that has one valence electron. And so we can model that valence electron in a dot diagram. And so a dot diagram has the element symbol with the number of valence electrons surrounding it. So hydrogen has one valence electron, so it has one dot around it. Oxygen has 6 valence electrons. You can see that here. And so oxygen's dot diagram has 1, 2, 3, 4, 5, 6 electrons surrounding it. So when a water molecule forms, we have 2 hydrogen atoms and 1 oxygen atom, and contributing their valence electrons. And so the valence electrons like to be paired up when they do this bonding. And so we can see that this electron, there's an open spot here and an open spot there. And so this hydrogen electron will probably slide in and pair up there, and this hydrogen electron will slide in and pair there. And so this satisfies the octet rule. And the octet rule says that elements strive to have 8 valence electrons. The exceptions are hydrogen and helium. And that would be because if hydrogen gets 2 valence electrons, it completes that first energy level and it would be full. So when water shares these electrons, oxygen now has the 8 valence electrons surrounding it, and hydrogen then has 2 valence electrons surrounding it, which is what it strives to do. So all of this creates chemical compounds. They have the same or fixed ratio of elements, and they will always have the same composition. So I think we've talked about that quite a bit, in that water always has the composition H2O. It will never change from that. So we have to look at the chemical formulas. They really help tell us the elements involved and the quantity of each element involved in the bonding. So chemical formulas use the chemical symbol of the compound, using the element symbol and subscripts to show the ratio of the atoms in the compound. So if we look at the table, we have 4 different compounds, 1, 2, 3, and 4. And each compound shows us their dot diagram, their electron dot diagram. And it shows us the number of atoms of each, and then its chemical formula. So hydrogen chloride has 1 hydrogen and 1 chlorine, so the chemical formula is HCl. Methane, on the other hand, has 1 carbon and 4 hydrogens, So its chemical formula is CH4, and this subscript 4 indicates that there are the 4 hydrogen. We do not write the subscript 1. We don't need to write a 1. Anything greater than 1 we will indicate. So hydrogen peroxide has 2 hydrogens and 2 oxygens for a formula of H2O2. And then carbon dioxide has 1 carbon and 2 oxygens for a formula of CO2. If you look at carbon dioxide's dot diagram, you're going to notice these 2 locations have 4 electrons being shared there. And that's something we call a double bond. And we'll talk about that in a couple more videos. So let's practice writing chemical formulas. So we have a molecule of something called ammonia, and it has 1 atom of nitrogen and 3 atoms of hydrogen. So it wants us to write the chemical formula. So the first step is to know your element symbols, and nitrogen is N, and hydrogen is H. And so now we can look at the subscripts. Nitrogen has 1, so we don't need to write the 1. And then hydrogen is 3. 3 is greater than 1, so we do have to write the 3. So our formula here is NH3. Our next example, we have a molecule of nitrogen dioxide, has 1 atom of nitrogen, and then 2 atoms of oxygen. So again, start with your symbols. We have nitrogen, and then oxygen. And then we have to worry about the subscripts. So on nitrogen, it's only 1 atom, so again, we don't write the 1. And then on oxygen, we have 2 atoms, so we would need to indicate that with a 2. What we are going to come across here is what we call prefixes, or the start of the word. And so some of these prefixes will indicate quantity. So like the prefix di already indicates 2. So it will get to a point where you will be expected to write the chemical formula just based off of this name. And so I think you might be familiar with like tri would equal 3, mono is 1, tetra is 4, penta 5, hexa 6, hepta 7, octa 8, and I think that's about as high as we need to go. So a lot of times what we'll come across is that many different compounds involve the same elements. What makes them different is that the ratio of their atoms is different. So if we look at the 2 examples here, we have water as H2O, so it has hydrogen and oxygen, which makes it water. But if we add a second oxygen atom, we now get hydrogen peroxide. Again, it's similar to water in that it's odorless and colorless, but it's used as an antiseptic to help clean out cuts. And it can be used as a bleach as well. Carbon dioxide and carbon monoxide, again, both have carbon and oxygen, but the difference of 1 oxygen atom can change it from something you exhale when you breathe to a substance, carbon monoxide, that would kill you. There are different types of compounds, and they're different because of how their bonds are formed. The type of bond will determine many properties of a compound, and there are 3 types. We have ionic, covalent, and metallic. And so each of the next videos will cover these types of bonds.